Now let's take a look at the relationship between different units. And here we're going to look at several different units for length. And what we're looking at the relationship between basically are metric units and English units. So 1 kilometer is 0.6214 miles, a meter, a little more than a yard, 39.37 inches. And here's the relationship between a meter and a yard. A foot is 30.48 centimeters, and 1 inch is 2.54 centimeters. Now here it tells us that this is exactly, remember for our purposes, we're going to consider all of these relationships to be exact. Now we're going to refer to these relationships as equivalent statements, and these tell the equivalent or the relationship between two different units. Here are some relationships between the metric mass units, and this is the wrong unit here. Kilogram is going to be a kg. Oops, lowercase g. There we go. A kilogram is 2.205 pounds. A pound is 453.59 grams, and an ounce is 28.35 grams. You do not need to memorize these conversion factors, but you will have to apply them, and you will need to find them. These are in your textbook, and they will be given to you on your in-class quizzes and exams. Now here we have two conversion factors that relate metric units. 1 liter is 1,000 milliliters, and 1 liter is 1,000 cubic centimeters. And we remember that a milliliter is equal to a centimeter cubed. A liter is 1.057 quarts, and 1 gallon is 3.785 liters. Now, one set of conversion factors that you will not find in your textbook are the English to English conversion factors. And what we mean by that are the conversion factors that we use in our everyday life, such as 12 inches equals 1 foot, or 4 quarts is equal to 1 gallon. And then this actually works in metric as well. 60 seconds is equal to 1 minute. These conversion factors you are expected to know. Now let's look at metric to metric. Some of you may already be familiar with some metric to metric conversion factors, and we've already reviewed two. 1 centimeter cubed is equal to 1 milliliter, and 1 decimeter cubed is equal to 1 liter. But what I'm going to be focusing on now is mostly the relationship between prefixed units and base units. Many of these conversion factors will not be written out for you, and it's important that you know how to write these out correctly. The key to this is to always follow the same exact pattern. And I'm going to go ahead and look at the relationship between micrograms and grams to show you how this pattern works. You always start out with one of the prefixed unit, and then you write the equal sign, and then you start what I call a translation process. So we have a 1 on the left hand side, we come over here and we draw a 1. We have a gram on the left hand side, and we come over here and we write a gram. And then lastly, we take a look at our prefix. Our prefix is always going to translate as some power of 10. And what that power is what we refer to our table for. Here's the table that relates the symbol with its equivalent power of 10. So if we look down at this table, we see that micro stands for 10 to the minus 6. So we go back to our conversion factor and we write 10 to the minus 6. Now let me just show you a common mistake, which is writing 1 gram is equal to 1 times 10 to the minus 6 micrograms. This is completely incorrect, and it will get you the wrong answer. What you want to do is, when you write out your conversion factor from prefix to base, is make sure you do this translation process and that your prefix is on the opposite side of the equal sign from your power of 10. So you want to make sure that you never do something like this. You are always going to start out with one of your prefixed unit and on the other side your base unit will have a power of 10. Now I chose gram as my base unit, but this prefix works for any physical property that we're going to look at. 1 microliter is 1 times 10 to the minus 6 liter. 1 micrometer is 1 times 10 to the minus 6 meter. So again, we want to be super careful that it's always one of the prefixed unit, and then we do our translation, 1 to 1, our prefix to the power of 10, and then a base unit on both sides. Each one of these components is incredibly important, and if you leave any of them out, you will be in for a hard road to do your math that we're going to go into next. If you would like some more practice in writing these conversion factors, I have an extra worksheet available to you that you can print out, and that will give you some more practice. Okay, so let's review conversion factors. There are 3 types of conversion factors. The conversion factors that go between English and metric, some of which you may know, but in general you're not expected to know these. These will be given to you on any quiz or test. English to English, such as the relationship between feet and inches or quarts and gallons, and you're expected to know these. And then last, metric to metric. And there are a few that don't deal with the prefix These two are not related through the prefix relationship, but you do need to know how to get from any prefixed unit to the base unit. And remember, we translate our 1, we translate our base unit, and then we translate our prefix to its power of 10. And if we were to look at the table, we would see that kilo means 10 to the third. And then we could use any base unit here. 1 kiloliter is equal to 1 times 10 to the third meter. So we're going to make a great deal of use of these conversion factors, so it's important to know where to get them. Now let's take a look at the relationships between these different values, and if you would, pause the lecture for a few minutes and figure out which in each pair is larger. And the key to finding this out is to look at the conversion factors. A meter is larger than a yard, just slightly by a few inches. A mile is larger than a kilometer. An inch is 2.5 times larger than a centimeter. A kilogram is larger than a pound. It's about 2.2 pounds. And this one, you had to look at the prefixes to see which one was larger. Milli is 10 to the minus 3, and micro is 10 to the minus 6. So milli, 10 to the minus 3, is going to be larger than 10 to the minus 6. Looking at the conversion factor, a liter is slightly larger than a quart, and a gallon is much larger than a liter, and a gallon is also much larger than 1,000 centimeters cubed, which is equal to a liter. Now we're going to take a look at units in terms of the math that we are going to do with them. When we are doing our math in chemistry, we will 99 times out of 100 have a unit associated with the number, and it is extremely important to write down the unit with every number. You must include the units in your calculations, and when we do math, not only are we going to be doing math on our numbers, but we are going to be doing math with our units. And here's some things that we want to remember with our units. They're going to follow the same kind of rules that numbers do. If we multiply a unit by itself, then that unit is squared. When I add two values of the same unit, the unit stays the same. And if I divide two values that have the same unit, the unit will actually cancel out, because anything divided by itself is equal to 1. So let's look at some examples of this. So if I have 3 centimeters times 2 centimeters, I'm going to multiply my number part. 2 times 3 is 6, and then I'm going to multiply my unit. Centimeter times centimeter is centimeter squared. And this answer is actually expressed in correct sig figs. The rule for multiplication is our answer has as many sig figs as the value with the least, and each of these have 2 sig figs. Now let's look at addition. If I add 7 mils to 4 mils, I'm going to get 11 mils. My unit stays the same. The same with subtraction. So in both cases, I've expressed my answer in correct sig figs. Neither of these values have any places after the decimal point. My last significant digit is the ones place, which is the same in my answer. And the same thing here. Since I've got a whole number with a trailing 0, I went ahead and put a decimal point there, since this really is my last sig fig. In both of these values, there's no places after the decimal point, and my last sig fig is in the ones place. So this is correct sig figs. Okay, now let's look at the division part. If I have 9 kilometers and I divide it by 3 kilometers, and let me just point out that this fraction bar means division. I'm going to look at my numerical part. 9 divided by 3 is 3, and then kilometers divided by kilometers is 1. So we use the term cancel out to express what happens here, because what we have is then 3 times 1, which is 3. So our kilometers cancel out. Any time a unit is divided by itself, it essentially cancels out. And we're going to use this feature of numbers and of units throughout our next section when we look at our math. What we're going to be spending a lot of time doing in chemistry is getting from one unit to another, and that is a process known as dimensional analysis. Dimensional analysis is a systematic way to approach going from one unit to another, and the key to doing dimensional analysis is conversion factors. And we've looked at the different ways to get conversion factors. Metric to unit we get from our textbook. Metric to English we get from our textbook. English to English you know from your everyday life. And then metric to metric, a prefixed to a base unit, we get using the procedure that I outlined in the last lecture. Now for our purposes, we're going to consider all conversion factors to be exact, whether they're measured or not, because that's going to help us with the sig figs. Our conversion factors are going to have an infinite number of significant figures, and we'll see that that will not have an impact on our final significant figures in our answer. Okay, now let's look at conversion factors again. We've already looked at conversion factors in terms of this equivalence statement, writing them out as an equality. What we will be using these values as, mostly in our math, will be in this fraction form, where 1/2 of the conversion factor is going to be on in the numerator on the top, and the other half is on the bottom. And we'll see when we look at how dimensional analysis actually works, which goes on top and which goes on bottom. That's very important, but it is relatively simple to figure out. When we do dimensional analysis, we are going to follow a systematic approach. We will always write down the given amount and unit. We will always write down what we want to find and its unit, and we will always write down the needed conversion factors. And the last step is to do the math. I call it railroad math. And what I'm going to do is look at an actual problem to show how it all pans out. So here's a typical problem. How many nanoseconds are in 2 days? Okay, so first we've got to identify what our given value is. That is the value that has a number and a unit, and that's going to be 2.0 days. And then I'm going to identify what I want, and that is nanoseconds. Now, what I'd like you to do is pause the lecture and think a few seconds about some conversion factors that you could use to get from days to nanoseconds. Okay, let's see if we were on the same track. This is what I got. I looked at days, and I said, well, from days I can get to hours, and from hours I can get to minutes, and from minute I can get to seconds. Now how can I get to nanoseconds? Well, I know I can get from any prefixed unit to the base unit through the technique I described earlier. We always have one of our prefixed unit, and we translate one to the other side, we translate the base unit to the other side, and then we translate our prefix as a power of 10. And if you look back at your table, nano means 10 to the minus 9. Now, one question you may ask yourself, maybe in this problem or other problems where you're dealing with units you're not that familiar with, how do you know when you have enough conversion factors? Well, what you need to do is, if you write out your given and your want, and you look at all the units in your conversion factors, you should have 2 of each unit. You need 2 of each unit to go forward with the math. If you don't have 2 of each unit, then you're missing a conversion factor. So let's go ahead and check to see we have 2. All right, here I have days here, and I have a day here. I have hour here, and hour here. Minute here, second, nanosecond, and nanosecond. So I have 2 of each unit, so I know I'm ready to do the math. Okay, so before we go on, let's do a quick review. The first step that we want to do is write out our given and our wanted. The second step we want to do is we want to write out our conversion factors. This may take the longest amount of time. And then step 3 is to actually do our math. And this is let me show you in chemistry land how we do this math. We do what's known as railroad math because we set it up like a railroad. And in our first compartment, we always have our given value. So we've already written out our given, so all we need to do is go up here to see what our given is and write it down here. This is the key. Once we have our first unit, we know where every other unit is going to go, because we remember that a unit divided by itself is 1, and we want all of our units to cancel out except for nanosecond. So I have days here. I want to put days down here, and I have a conversion factor that has day in it. The day goes on the bottom, and the other half goes on top. So because this day is on top of the fraction bar and this day is on the bottom of the fraction bar, it's day divided by day, which cancels out. This line, by the way, represents our fraction bar, and it represents dividing what's on the bottom. So now I have hour. That's not the unit I want, so I'm going to go up and find a conversion factor that has hour in it that I haven't used. I've already used this, I've already used this one, so let me cancel this one out. So here's the conversion factor that I use. 1 hour goes on the bottom, and then the other half goes on top. So then my hours cancel out, hour divided by hour. Now I have minutes, and that's not the unit that I want, so I need minutes down here. And I go back up here. I've already used this conversion factor. I can't use it again. So I'm going to look to this one. Minute will go on the bottom, and seconds will go on top. So our minutes cancel out, and now I have seconds, which is still not the unit I want. And I look up here, I have one conversion factor that I haven't used. I want the seconds part on the bottom, and so my seconds cancel out, and I'm left with nanoseconds, which is the unit that I want. So every placement of which part of the conversion factor goes on top and which goes on the bottom was determined by my given value. I had days here, so I wanted days down here. I had hours up here, so I wanted hours down here. Minutes up here, minutes down here, seconds here, seconds down here. So you see why we have to have 2 of each conversion factor so they all cancel out. Now let's look at how to handle the math. In the top part, what these vertical lines indicate are basically the same as parentheses. So in the numerator part of our railroad, the top, we multiply everything, and then in the bottom we divide. So we do 2 times 24, then divide by 1. And then we take this answer, multiply it by 60, divide by 1. take this value, multiply by 60, divide by 1, and then take this answer here, multiply by 1, and divide by 1 times 10 to the minus 9. So when I do those operations in my calculator, I get 1.72 times 10 to the 14th nanoseconds. Don't want to forget your units. And let's look at sig figs. Because our conversion factors all are considered exact numbers, our only measured value is our given value. Our answer is going to have as many sig figs as the value that we started with, which is 2. So we look at our last allowable digit, we look to the right, that is not greater than 5, so it's 1.7 times 10 to the 14th nanoseconds. And this makes sense. This is a very large number, which we would expect to have a lot of nanoseconds in 2 days.